Welcome back to the Deep Dive. Today we're navigating a really fascinating convergence point.
We are. It's the intersection of cutting-edge algorithmic precision and the ancient, sometimes messy complexity of the human mind.
And the theme connecting them is decision-making.
It's a spectacular stack of sources we have. On one side, you've got this highly technical research showing how advanced AI models calculate, and this is the key part, how they explain their choices.
We're talking about transparency in the age of automation.
Exactly.
And then on the other side, we have these deep dives into cognitive science, even some timeless wisdom, looking at why this complex biological system make lightning-fast choices.
Right. Often before your conscious mind has even, fully registered what's happening.
It's the logic gate versus the limbic system, really.
That's a great way to put it. So our mission today is to pull the most important threads from this material. We're going to unpack the science behind things like decision trees and machine learning.
Get into the world of explainable AI, and then pivot completely to an analog tool.
A very powerful one. The intentional disruptive force of what our sources call the sacred pause.
The goal here is for you to walk away understanding how to better trust, or maybe distrust, both the machine's decisions and your own gut reactions. But let's start with the cold, hard logic of the machine. When we talk about how algorithms sort, classify, and decide, the foundational model is often the decision tree, the DT.
It is. For anyone not familiar, just think of it as a logical flowchart. That's really all it is.
A sequence of choices.
Exactly. Imagine a chart where each point, each node asks a question. Something simple like, is the customer over 35?
Or is the temperature above 80 degrees?
Right. And the answer determines which branch you follow next until you finally land on a leaf node. And that leaf is your final answer, your classification.
What's so appealing about it right off the bat is how easy it is to understand. I mean, compared to a deep neural network, which is this impenetrable black box.
The decision tree is what they call a white box model.
You can actually follow the path. You can see the logic.
That transparency is huge. And beyond that, they're just incredibly practical. They can handle all sorts of data numbers, categories, you name it.
You don't need to do a ton of prep work on the data, right? No hours spent normalizing every variable.
Not at all. And they scale beautifully to massive data sets. Our sources suggest they're probably the closest that machine learning has gotten to mirroring how we, as humans, consciously break down a problem.
But mirroring human reasoning isn't always a good thing, because even the cleanest logic runs into complexity issues. And what's fascinating is that decision trees actually prefer less complexity. They love Occam's razor.
That's the critical pivot. The simplest explanation is usually the best, but if you let a decision tree get too complex, you run straight into the danger of overfitting.
Which is when the machine starts seeing patterns that aren't actually there.
Right. It's not just a technical glitch, it's a reliability killer. It means the model has essentially memorized the training data.
Including all the random noise and flukes.
Exactly. Instead of learning the underlying transferable rules, it just memorized a specific data set.
And that's where the real-world chaos begins.
It is. Our sources give a couple of great examples. Think about weather forecasting. An overfit tree might see a tiny random blip in air pressure.
And build an entire complex new branch of logic just for that one anomaly.
And then the next day, that anomaly is gone and the prediction is wildly inconsistent.
Or in retail, with customer behavior. An overfit model might key in on something like purchase green socks on a Tuesday.
A completely random detail. And if you run the data again, and that person bought blue socks on a Wednesday, the tree might throw them into a totally different category.
Even though their core behavior hasn't changed at all, the model is just brittle. It's useless.
So the goal has to shift from just raw accuracy to reliable, trustworthy accuracy. And that brings us to the rise of explainable AI. XAI.
The whole point of which is to demystify these models, to make them understandable to the non-experts who have to use their outputs for big decisions.
Like loan approvals or, say, medical diagnoses.
And one system making huge strides here is KAXAI. It's this integrated environment that throws a lot of firepower at the problem.
It really does. It combines automated machine learning, XAI tools, and even synthetic data generation. They're trying to get both predictive accuracy and full transparency.
And they didn't just use standard models. They proposed new ones, like the logistic regression forest and the support vector tree. And the results are pretty compelling.
Extremely high accuracy, over 97% on certain medical data sets, which is, a very strong validation.
But the real insight for me is how they interpret the black box. They use this interpreter called Medley, but what I found fascinating were the metrics.
You're talking about permutation importance and drop column importance.
Let's focus on drop column importance because it's such a brilliant, simple idea.
It really is. It works by just evaluating what happens if you completely remove a feature. Take age or income out of the credit model, set it to neutral, and see how much the prediction changes.
So it literally tells you, with a hard number, which features are pulling the most weight in the final decision.
It's like machine introspection. The algorithm is asking itself, if I ignore this one thing, how much does my answer change?
Exactly. And in a slightly different area, the system also uses Jan's generative adversarial networks to create synthetic data to train on.
Right. And they found that for numerical data, bulking up the original data set with these high-quality fakes leads to much more reliable training.
It just underscores that even the smartest models need really well-vetted inputs to work.
Right.
So for the machine, the path to a reliable decision is transparency and great inputs. But now let's flip the script. Let's talk about the human decision system.
A completely different animal. Unlike an algorithm, we face problems that are, massive in scale, uncertain, and we have to decide in seconds. Formal analytical methods they seize up.
They dissolve entirely. The cognitive science sources we looked at describe the human brain as a flexible response mechanism, an FRM.
It's designed to find approximate or just good enough solutions in a messy world. It's not looking for the perfect, optimized answer.
And here's the part that is just deeply counterintuitive. It really challenges our basic sense of self. The research says that consciousness does not have an active, executive role in our behavior.
That's the shocker, isn't it? We feel like we are the captain of the ship.
Right. I feel like I'm making this choice right now.
But the evidence suggests that conscious experience, the sights, the sounds, the feelings, that internal voice, it's primarily input data that gets fed to the deeper, non-conscious system.
So if consciousness is just the display screen, then why have it? Why do we have this powerful feeling of agency if all the heavy lifting is being handled by these non-conscious processes?
It seems to be a mechanism for flexibility, not for execution. Think of the non-conscious system as this massive engine processing millions of data points, and then it generates a response.
And consciousness is for reviewing it.
It allows for self-monitoring, for refining those responses over time, and maybe most importantly, it lets us explain why we did something.
Even if that why is just a story we tell ourselves after the fact.
Exactly, a post hoc rationalization. We are built to find an explanation, even if it wasn't the actual driver of the action.
This lines up perfectly with the dual process theory, that split between the slow, analytical system and the fast, intuitive one.
The blinking intuition. Quick, instinctual, and based on past knowledge that we aren't consciously digging up.
And that rapid system is completely tied to emotion. You can't separate them.
Trying to make a decision without any effective input is almost impossible. The sources confirm that our past experiences, they don't just leave memories. They create these subconscious emotional valence tags.
Like little good or bad sticky notes on things.
That's a perfect analogy. They instantly attach themselves to potential choices. So when you use your gut feeling, you're not using some mystical power.
You're using a lightning-fast system of emotional shortcuts built from decades of experience. The valence tags bias our choices, helping us trim down a paralyzing number of options.
It's incredibly efficient, but efficiency has a cost.
Because sometimes those valence tags are driven by old fears or outdated wants.
Right. Our sources call this the hungry ghost syndrome. When the mind gets stuck in these non-conscious loops, chasing desires or running from fears, that's when instinct goes wrong.
And that is our cue to bring in the ultimate analog tool, the sacred pause. This is where ancient wisdom meets modern emotional regulation.
It is the intentional disruption of that habitual loop.
And it's more than just taking a deep breath.
Much more. It's an intervention. The pause is the deliberate insertion of a beat, a moment of stillness between a stimulus and your knee-jerk reaction. What it's doing is disrupting the neural pathway that's driving that habit.
It's an act of sovereignty, really. By stopping the reaction, you create a space for a new, more intentional response to emerge.
You're basically shining a spotlight of consciousness onto that non-conscious valence tag that was about to drive your behavior.
You're forced to see the underlying want or fear that makes up that hungry ghost.
And the science backs this up. A pause of even just 20 seconds can literally shift your biochemistry, letting the rational prefrontal cortex get back in the game and override the more reactive parts of the brain. You're building the muscle of response flexibility.
So if we pull back and look at the whole spectrum, both complex AI and the human mind struggle with limits. with runaway complexity. For the machine, the ultimate ceiling is still Alan Turing's halting problem.
Right. The halting problem proves that you can't create an algorithm that can reliably predict if another complex algorithm will ever stop or if it will just run forever in a loop.
It's a massive theoretical and practical challenge for AI.
Absolutely. It leads to infinite loops and unpredictability.
Humans, thankfully, don't usually get stuck in infinite computational loops. We do struggle with deep recursion, though.
We do. We can usually only handle about 3 levels. Knowing that we know that we know. After that, it gets fuzzy.
But unlike AI, we thrive in open-ended worlds.
And the hypothesis there is just fascinating. Our adaptability might come from our consciousness being fundamentally embedded in the flow of time and entropy. We process forward. We don't just run in cycles. It's an escape hatch a deterministic machine just doesn't have.
And here's where the source material takes a major philosophical turn. Some models propose that the brain isn't just like a decision tree. It is a decision tree, a complex one whose job is to constantly reduce reality.
That's a massive concept to wrap your head around. Instead of building up complexity, this model says the mind's job is to take this infinite, undifferentiated state of experience,
Sometimes called absolute unitary being, or AUB.
and reduce it down into the concrete, manageable, limited human experience we call reality. Our perception right now is just one branch of an infinitely larger decision tree.
So our ego mind, the self that feels fear and desire, is just the product of that reduction process. It's not the one running the show.
Exactly. And if you follow that logic, then accessing certain deep states of mind, say through intense meditation, lets you temporarily bypass that reduction engine.
You can reset the mind to a state of, as the source says, no emotion, no fear, no striving.
Because you've momentarily stepped outside the reductive loop of the ego.
And that reset gives you what the source calls the sovereign choice, the ability to choose whether you re-engage with that ego mind or just reside in that non-dual state.
It's the ultimate conscious decision, totally free from those valence tags or non-conscious biases.
But whether we're dealing with cosmic complexity or just computational variables, the final step is always the same: evaluation.
Just like KXAI uses drop column importance to evaluate the influence of a feature, we have to evaluate the influence of our own assumptions.
This brings us back to a really powerful mental model: first principles thinking. Most of the time, we make decisions based on analogy. This problem looks like that last one, so I'll use the same solution.
First principles thinking demands you reject that shortcut. It forces you to break a problem down to its fundamental, irreducible truths, its core elements, and then reason up from there.
It's the highest form of self-monitoring. Challenge every assumption.
And it provides a massive competitive advantage. It's the human version of tearing out a feature with drop column importance just to see if the whole model collapses. You're asking, if I remove the conventional wisdom, is the underlying truth still sound?
And one final necessary reminder in all this: the machine is an incredible tool, but it doesn't solve the judgment problem.
Not at all. Whether you're generating synthetic data with GANs or relying on predictive models, it always comes down to human evaluation, to domain knowledge. Someone has to subjectively assess if the results are plausible before making a big decision.
We've gone from the intricate branches of the algorithm's decision tree through the non-conscious machinery of the mind and out to the edge of philosophical choice. For the machine, the goal is total transparency XAI.
And for the human, the goal is intentional presence. And that's achieved through the deliberate stillness of the sacred pause. Both are tools designed to pull you out of a habitual loop, whether it's computational or emotional.
So what does this all mean for you? You have to navigate a world that's constantly driven by complex and often opaque decisions, whether they come from a transparent algorithm or your own, opaque instinct.
So consider this. The most efficient machine learning models constantly require a huge amount of human effort to explain their outputs and validate their data. If cutting-edge science relies on continuous human assessment and trust, what critical questions should you apply to your own instantaneous, non-conscious decisions, those gut feelings, before you let them determine your next action?
And that is the space created by the pause. And that is the most important question for you